Hi there, I'm Pat Vaughan. I'm the Chief Operating Officer here at DCN, and my role is to lead all the development programs here on site. Okay, so you may ask, what's the typical timeline for developing a lateral flow assay? So a lot of that, the first step is, well, what's the analyte? And if it's an antigen or a protein or a viral particle or something that we're detecting, we want to go and find antibodies that are specific to that target. So we need to either buy those commercially, or in the instance where they're not available, they have to be developed separately. So you have to go and inoculate mice or rabbit or whatever it is, generate the antibodies, which can be a process that can take several months. But typically, the antibodies are available, so we take those and then we start screening all the antibodies that are available and take them through right through the process. So the process starts with feasibility, where we take the basic reagents, apply those to some commonly used materials, and do early prototype generation. Typically, feasibility is about 2 to 3 month time frame, where at the end of that we can say, yes, it's possible that we can go ahead and develop this assay. The binders, as in the antibodies, are working. We can detect the antigen in the specific sample, and we have a basic set of raw materials that can be used for that purpose. Now, if everything is at the end of that phase, if everybody agrees that between us and our client that it's feasible, we take it in through the next phase of development, which is optimization and development. And this whole phase structure is very, very important to follow good design control, which we do here at DCN. So during optimization and development, what you're doing is basically taking the prototypes that you had at the end of feasibility and now saying, how can I make this a reproducible, robust manufacturing process? So you optimize the design, you tweak the different parameters until you come up with something that can work over and over again, where you use different lots of reagents, different manufactured lots of your antibodies or your membranes or your pads and so forth, and you can always derive the correct result. So you always get a test that's meeting the set forth criteria or QC release criteria. So that's at the end of phase 2. At that stage, you have a valid design, you've verified the design, you've validated the process in which to manufacture it in higher volumes. And what you say then is that this is a fully developed and optimized test, and you are going to freeze the design. So you reach design freeze, and then you're into the next phase, which is transfer to manufacturing. That's where you've proven the design, you've proven the process. You can take all those manufacturing records that you've developed in phase 2 and now use them in the manufacturing phase and produce millions of tests to the same quality and that they meet the same performance criteria as you did during development.